Radhe Radhe everyone. So what is up guys? Everything is good I guess, okay. So you guys can hear me? Actually you can't see the comments over here, it takes time to load. But yeah, for me I can see the comments. So yeah. Okay, so now it is visible. Correct? Okay, let's before starting, okay, let me just check my audio once and then I'll can start with it, I guess. Sad. Okay, so for today's video, we will be covering all the problems because we have basically done all the. Okay, I forgot to check the audio because we have done all the questions. So before starting the video, so one thing that is this 2460. Okay, this is the subscriber count before starting the video. We are targeting for 2500. So that is basically nothing but 40 more people. Okay, so if we can get 40 more people, that's basically awesome. Nothing else. So should I wait for more people to join or should I start? Okay, someone is watching, and yeah, one before. Let me just check now. Okay, great. So so that's it. We are targeting for 2.5k. Okay, this is the rating of the previous contest. And anyways, I have put a discuss link on. I have put a comment on a discuss link. Okay, I'll ask you guys to go and upvote it. Uh, it is basically um, my wrap of 2025 lead code. So I've put it up on lead code's official discuss comment. Okay, so I'll put up the link. Okay, let me do one thing. Let me put up the link over in the comments real quick. And once it is put up, you guys can go and upvote that specific comment. Okay, this is it. Let me pin it. Okay, so this is it. Okay, so let's start with the first question. And people, if you can't what to say, if you can't write anything in the live chat, it's because I've turned on subscribers only. So I want you guys to be a little bit interactive, and since it is subscribers only, please do subscribe my channel and then start trying. Okay. Okay, let's go. So the first question is maximum score of a split. You're given an integer array nums of length n. Choose an index I such that the I is less than n minus 1. For a chosen split index I, prefix sum is the prefix sum, you know what it is, from 0 to I, the sum of all the elements. And suffix min is the minimum of all the elements after that. Okay. The score of a split at index I is defined as score of I equal to prefix sum minus suffix min. So this prefix sum minus suffix min, you have to return the maximum score that you can have. Now, one important thing is that since you are just traversing once, okay, you are just traversing once throughout the whole thing. So this prefix sum won't be a big issue, okay. For every element that you get, you can add it to the prefix sum. That's not an issue. The main issue is the suffix min, right? So you have to find, you have to take an array out of it. You have to make an array of suffix min, okay. And inside that array, you have to put the stuff. I don't know why my laptop is lagging a little bit. It's not OBS, it's my laptop that is lagging. But anyway, it's not an issue. I think it is because of a lot of things are getting loaded. Let me just move on through all of them. And now I think the lag should be better. I mean, the lag shouldn't be there. Don't check my rankings. Let me cross it up. Okay. So the suffix min is the most important part that we have to consider. Okay. So let's look at the solution. The suffix min is like I'm taking an array of size n, and suffix min of n minus 2 is equal to nums of n minus 1, because like if you're standing at a position, the suffix min is the minimum of all the positions after it, right? So if I'm standing at the second last element, what is the suffix min? It is the last element. If I'm standing at this position, what is the suffix min? The suffix min of this and this element, whichever is minimum, we have to keep it, right? So that is the suffix min. So initially, the second last is the last element, and for all the remaining ones, it is going to be suffix min I plus 1 and nums of I plus 1. Whichever is smaller, we are going to keep it. Okay, you get it? Then you have the prefix sum. It is initially 0. Answer is initially the minimum value that you can have at any position. I'm not sure why this is happening. The laptop is on charge. Okay, so this is the basic idea of the whole thing. Okay, now let's try to go through the traversal that I have done. It is nothing but I run from 0 to n minus 1, because it is like it was given that it is n minus 2 and stuff. So I run from 0 to n minus 1, and then I go on adding nums of I to it, okay, to the prefix sum. And you know what the answer, the score is? The score is prefix sum minus suffix minimum, right? So that is what I've done. So any doubts on this, guys? I'm not sure if I'm lagging or not. Actually, I'm lagging, I guess. Let me do one thing. Let me remove this. If this fixes, removing this, if it fixes it, then I think I know the issue. Okay. So yeah, I think this was the issue only. So there was a long polling thing that I've done. So that was taking the stuff from the backend. So yeah, it should be good. So I hope this was a very simple question. So you guys won't be having any doubt on this. So let's move on to the next question. The next question is minimum cost to acquire required items. I'm really amazed to see that LeetCode is going quite easy with problems these days. I don't know why, but it's good to see. So this problem is that you're given 5 integers, cost 1, cost 2, cost both, need 1 and need 2. Okay. An item of type 1, cost 1 and contributes 1 unit to type 1. Item of type 2, cost 2 and contributes 1 unit to type 2. An item of cost 3, cost both and contributes 1 unit to both of them. Okay. So there are few things that you can do. There are few. Okay, so first let me first complete the question. You must collect enough items so that the total contribution toward type 1 is at least need 1, and the total contribution towards type 2 is at least need 2. You have to return an integer representing the minimum possible cost that you can have to achieve this requirement. Okay. So if you want to have the minimum possible cost to achieve this specific requirement, so it is a little bit tricky. Okay, it is a little bit tricky. So that is the question may seem to be it is a medium question. Okay, it is given that it's a medium question, but the main trickiness of the whole question is that there are only three possible ways you can do this. Sorry, there are only four possible ways you can do this. Okay, so you have to find whichever of the four ways it is giving the minimum answer. Actually, there are three because the second possibility has got two outcomes. So basically, it is three, but yeah, you can go with four. So what are the four ways? So first way, it is very clear. Instead of putting buying cost 1 or cost 2, we just eliminate cost 1 and cost 2. And whatever need 1 and need 2. Okay, so let's say need 1 is 3 and need 2 is 2, right? So if I'm thinking that I want to solely buy cost both, okay, if I solely want to buy something which leads to cost both, then what I'll do is I'll take need 1, I'll take need 2, whichever is maximum, I have to contribute that to the cost both. Okay, I have to buy that number of cost boths. Correct? So that is the first scenario. I'll show you. So if you look at this, it is like int both needed is equal to, okay, so I'm taking a variable called both needed, where what I'm doing is I'm checking whichever is maximum, need 1 or need 2. So answer is equal to both need into cost both. So this is the best, I mean, this is one of the simplest way to do it. That is, I know that this is going to contribute to both of them. I buy whichever is maximum of them. So this basically satisfies my requirements. Correct? Now there comes two possibilities. One is need 1 is less than equal to need 2, or otherwise need 2 is greater than need 2 is less than need 1. Okay, there are two possibilities. So if need 1 is less than equal to need 2, it means that for need 1 number, you can buy cost both. And for the remaining, that is need 2 minus need 1, you can buy cost 2. Correct? Then also requirement is getting fulfilled. Okay, this also fulfills our requirement. And then answer is equal to mat.min answer comma sum. That is whichever is the best. Till now, first of all, we bought both of them. I mean, we bought the one which is going to satisfy both of them. Then we sacrificed. That is, okay, for need 1, for this minimum number, let me buy cost both. And then for the remaining need 2 minus need 1, let me buy cost 2. Okay. But there is a trick over here. If you want to make it more simple, even though this is bigger one, if you want to make it more simple and more arithmetically mathematical, okay, I don't know what I'm saying, but if you want to make it like that, so what you can do is, instead of keeping it like need 1 less than equal to need 2, you can simply directly also say that you do this only if the cost 2 is less than cost both. You only do this when this is the case. Okay, otherwise you don't do this. Because if you look at, let's say if cost 2 is greater than cost both, so what is the cost of the whole thing? It is going to obviously exceed this, the earlier answer. So we don't need this. Okay, so there are various ways. If you want to make the computation more easy, so you can put a and over here also. That is cost 2 is less than cost both. Okay, you can put an and over here, but for our concern, I don't think we would do that because we don't need to do that. That is too much of complexity. Okay, we don't need to do that. Whatever is not needed, don't do it, specifically during contest. Okay. I don't know why my FPS is getting a little low. It is coming as 28 now. It is again shifting to 7. I don't know why my FPS is getting low. I think because the encoding is, I think there's some problem with OBS today. Okay. So yeah, that's it. So this is a need 1 less than equal to need 2. This is this condition. Okay. There is another condition that is need 2 is less than need 1. So in that case, you do the same thing. Just reverse need 1 and need 2 and cost 1 and cost 2. Okay. That is, you buy need 2 elements using cost both. So need 2 is satisfied and need 1 is partially satisfied. That is need 1 minus need 2 is still left. So that thing you can buy it using cost 1. Okay, and you get the answer for this. And the final condition, these are the three conditions that I've already said. The final condition is that you don't use cost both only. Okay, you don't use cost both. You use cost one and cost two. So cost one you use need one times, and cost two you use need two times. Okay, so that is this. Okay, is this because of this thing? This close. Now I think, yeah, now it is going better. So I think this close is getting something, some issues. Okay. Got it. So this is it. Okay, answer minus suffix. Sorry, not this one. So this is it. That need one into cost one plus need two into cost two. So you get the answer of minimum of that also. So basically, if you look into this question, it was very simple. There are there are two requirements basically. One is the need one. Second is the need two. The cost to buy a requirement of this is C1. The cost to buy a requirement of this is C2. But you can buy both of them using C3, let's say. Okay. So that is the whole thing, that what you're going to do. Okay. There are various ways to do this. You can also check that if C3 is greater than cost 1 plus cost 2, then you don't use only C3. Okay. And if it is not so, then you have to use C3 no matter what. Okay. So there are specific ways to do this. This is, you can check, you can put a check on C1 plus C2. But since you know like there are only 4 possibilities, so you don't need to do this only. If let's say this is less than equal to C3, okay, then you don't need C3 only. Okay. Otherwise, we have to check if C1 is less than equal to C3 and C2 or C2 is less than equal to C3. That these two conditions I have already said. Okay, that is while you were pruning those if and else, you could prune it also on basis of this. So there are specific things that you can do, and if none of them satisfies, then you have to take C3. Okay, so that is the basic core of the whole thing. Okay, that is, if this is satisfying, if this doesn't satisfy, take C3. If this is satisfying, then you have to check C1 less than equal to C3. Yes. C2 less than equal to C3. Yes. If both are satisfying, then you take C1 and C2 separately. Okay. Sorry, I think I messed it up. If both are satisfying, you have to take you have to take C1 and C2 separately. If both are not satisfying, then obviously you have got it. If either of them are satisfying, so this is basically the 4 possibilities that you have to check. But instead of making it too complex mathematically, my suggestion is, you have need one, you have need two. Okay. Whichever is maximum, try to buy both for them. Okay. Your requirement is satisfied. You have need one, you have need two. Put C1 on need one and put C2 on need, sorry, two. And put C2 on need two. Okay. Another possibility. You have need one, you have need two. Put buy both on need one, and whatever is remaining in need two, use that for, use that with C2, or the vice versa. Put buy both on need two, and whatever is remaining, put it on C1. Okay, whichever is going to give me the minimum among all 4 of them is my answer. Any doubts regarding this? I think I don't know why people are not that interactive. I think I can see people they are online. Okay, there are people watching this, but let me do one thing. Let me start a poll. Okay, if you guys can comment, just let me know. And if you guys can't comment, I recommend you to subscribe my channel and then subscribe, because I've put on subscriber only mode. Okay. Okay, so let's move on to the last. Sorry, the second last question. The third question was smallest all ones multiple. Again, as such, like I think all three of the first questions, the first except the first one, it was quite easy. The second and the third question, they so basically this is a more of a division type of thing. Okay, you know long division. There is a long division thing. So first of all, let me dude man. Okay, so let me just explain the question. You're given a positive integer k. Find the smallest integer n divisible by k that consists of only the digit 1 in its decimal representation. So it is like 1, 1, 1, 1, 1, 1, 1, 1. Okay. You have to return an integer denoting the number of digits in the decimal representation of n. If no such n exists, return minus 1. What does it mean? It means that there will be one, some number of times, okay. Let's say n number of times. And you're also given a number k. Yeah, n number of times, correct. You're having one n number of times, and when you divide it by k, the remainder should be 0, right? This is what it is telling us. So first of all, what we can do is, you put something, obviously you have to put 0 only over here, until unless k is 1, so you can put 1 and you're done with it. So you put a 0 over here, you get a 0 minus 1, and you get a 1 from here, right? That is what we do in the long division. Then you put some number, let's say it is 5. Whatever is the subtraction, you get it, and let 1 come over here. It is 61. If it is 5, then it's 61. So you get 61. Actually, it can't be 5 only. Let's say it's 7, okay. So it's 41, okay. It's 41. So what is the remainder? 4. The earlier remainder was 0. So let's focus also on the remainders. 4. You get 1. 41. So let's say k is 7, right? So not 17, it's 7. Now since it is 7, so 41, like it's going to be 7, 7 7 to 49, 49, 7 6 42, 7 5 35. We can have a 5. So we get 35. What is the difference of it? The difference of it is 5, 6. 6 and there is a 1, right? 6, another thing. Okay. Now let's say 61. So 7. So it's 8. Okay. 7 is a 56. So what is the difference of it? It is 5. 5. We get a 1, right? 51. So again it is 7. So 49, right? 49. So what do we get? 21, right? Then we get a 3 and 21. And we get the answer, right? So this is what you have to do. But the point is, what if it is not divisible? Then it will go on till infinite, right? If it is divisible, then we get the answer. Very simple. But if it is not divisible, then we don't get the answer. So that is the reason I was telling you guys that keep a track of the remainder at every step. Because for every time there is a remainder, we put 1 towards it, right? So let's say at any other position after this, if the remainder is 6, then we put 6 1. So basically we come back to this state only, right? So if there is a cycle, okay, if there is a cycle, let's say we go to 61 and then we come back to 61. So that cycle means that it will go to infinite loop. So we don't do that, correct? So that is the best thing to do. Now the point is that how to keep track of this? You can keep track of this using a set. Okay, a set is the best thing to do. So let's go through the implementation of it. it is like answer is equal to 1, remainder is equal to 1. Initially remainder is 1. Okay, you have to consider that. Why is it 1? Because it was given that k starts from 2. If k was starting from 1, then obviously we could have uh, given a base condition out of there, that is if it is 1 then return 1. Okay, that is a different thing out overall. So now answer is 1, remainder is 1. Okay, that is we have already got the 1. Now we add 1 to it because remainder is 1. While remainder is not 0, we have to do it, right? What does remainder become? Remainder becomes whatever it is, and towards its right a 1 is added. So what you can do is you can multiply it with 10, a 0 is added towards its right, and then you add 1 to it. So a 1 is added to its right. Okay, so remainder into 10 plus 1. Remainder mod is equal to k. Okay, why? Because we don't care about whatever is the divisor. We care about the remainder. Okay. So what is the new remainder? Now it is the mod is equal to k thing. Then for every specific, for every time the remainder is not 0, we add it to the answer. Okay. And once we get the remainder, we add the remainder to the set also. What if we have already visited the remainder? Then we can directly say that it is a minus 1 because there's a loop. Okay, I just explained you. So the loop is there. Okay. And ultimately you can return answer. So I guess there is no doubt regarding this because I feel that the comment section is quite low. So if it's okay, like if you guys are watching the pre-recorded version of it, you guys can enjoy that. Okay. Not an issue. So let's move on to the last question. Number of balanced integers in a range. Another brilliant question. You're given two integers low and high. An integer is called balanced if it satisfies both of the conditions. It contains at least two digits. The sum of digits at even position is equal to the sum of digits at odd position. Okay. Return an integer representing the number of balanced integers in the range low to high, both inclusive. So let's say, let's take it like this. That is, since you have to find balanced, ignore my handwriting. Since you have to find balanced in the range of low comma high, right? So this is basically nothing but balanced of 0 comma h high minus balanced of 0 comma l minus 1, right? This is what the whole thing is. So this 0 you can eliminate because it is the base. Over here also this 0 you can eliminate. So it is basically balance of h minus balance of l minus 1. This is what I have done also. Okay. Let me show you. Let me show you the solution of, no, I won't show you like this. For this question, I'll show you from here. Okay. See, I'm taking a fun because I usually write functions as fun during contests. It is easier than any other name to think of. So fun of high minus fun of low minus 1. Okay, that is it. Now the point is that you can't traverse throughout the whole array. Okay, brute force is never an option for this because high and low they are of 10 to the power 15. They can be 10 to the 15. Okay, so it can be like we go from 0 to 10 to the 15. So it's highly possible. So for that case, we can't do this. So let's look into fun. That is, let's try to divide the whole thing. Okay, how to do that? See, first of all, one thing that is, if n is less than 10, return 0. Why? Because it was given in the question that it contains at least two digits. So in this case, it would be having two digits. If it is less than 10, it will have one digit only. So return 0 directly. Otherwise, you have a string, convert that number to string, I have a DP. What is this DP basically? The DP is 1, 2, 3, 4, 5. The 5D DP. Okay, 5D DP. So yeah, that's a good one, right? Actually, that's very easy. Okay, actually that is very easy. So what it is given over here is that DP, I'm initializing it with few specific states. Okay, DP is basically nothing but states, and DP over here I'm using it for memorization. str of length, this is the whole traversal of the string, that is the whole number from the first digit till the last digit, or rather the opposite, from the last digit to the first digit. Okay, till the ones digit, rather you can see like that. Okay, or the first digit to the last digit. I think I was right only. So whatever it is, okay, it doesn't matter. So that is the length of the string. The second point, it is going to define the tightness. What does tightness mean? Tightness means that, let's say I have to find a number. Let's say I have to find a number which is first of all, let me make you understand tightness with greater than equal. Okay, so I have to find a number which is okay. So yeah, so let's say I have to find a number which is greater than equal to some number. Okay, so let's say greater than equal to 1, 2, 3. Okay, I'm finding a number. So let's say if I'm putting 1 over here and 2 over here. So what can I put over here? I have to put anything from 3 to 9, right? And what if I do the opposite thing? That is, I have to put something less than equal to 1, 2, 3. So if I put 1 and 2 over here, so in this position, I can put 3 or anything less than that from 0 to 3, correct? So these are the two positions. But let's say if at this position we already had a 3, so then it doesn't matter, we have to put a 3 over here. We can put a 0 over here also. We can put anything over here because we have already broken the tightness. Okay. Similarly for this, if this was a 1, okay, we have broken the tightness. We can put anything from 0 to 9, not necessarily 3. Okay. So this is the tightness. That is the first position where the tightness has been broken. If it is broken, then it is 0. If it is not broken, it is 1. So initially tightness is 1. Okay, because it is not broken. So tightness is 1. Start is basically this is basically start. So start is basically nothing but to find out that there are leading zeros or not. Okay, because if there are leading zeros, so it may happen like this. That is whatever we are considering. No? That is 0, 0. Let's say there is a 0, 0, 0, 1, 2. Okay. So what is the difference between odd and uh, even digits? It is, let's say, 1 and 2, right? So it is 1 minus 2, right? That is minus 1. But in actual case, if it is 12, these are the leading zeros, right? If it is 12, then the difference is the opposite. It is 2 minus 1, not 1 minus 2, right? So just to consider that condition, we have to keep a start also, just to check if it has started or not. Okay. If it has not started, so we have to put a type of that. Okay. So one thing is also there. That is from this start, is it very predictable to get from the start? Is it predictable to get what is the current position of it? It is kind of, but I don't prefer. Okay, because start is basically doing nothing, but it's like a boolean value. Okay, it's like a boolean value, that is, has it started? Yes or no? Simple. So since it's a boolean value, you don't keep that. You don't keep that specific thing in your whole array. Okay, so what you can do is you can have a length also. That is the length of the whole digits. So even if this is having a length of 5, the actual length of it is 2. Okay, and that is the last. That is the last one that we have in the D. Okay, but what is this 145? Okay, a specific number. What is it 145? 145 is nothing but the difference between the odd and the even positions. Why do I keep it 145? I'll tell you. Okay. So let's say it was given that there were 15 digits to be maximum. Okay, there are 15 digits. So among them, what is the maximum difference that we can have? So 15 can be divided between two parts for maximizing. It can be 8 and 7, right? And throughout all these 8, we can keep a 9, right? So 9 into 8 is nothing but 72, right? 72. So the maximum difference is 72. But we can also keep this like 7 and 8. Instead of 8 and 7, we can also keep it like 7 and 8. So in that case, it will be becoming minus 72, right? Now, one thing if you remember, that is, I was earlier also mentioning that this minus 1 and 1, this thing will happen, okay? This thing will happen, and we can't put the absolute value of it to check, because at the later state of the DP, we will be needing that, okay? So this 72 and minus 72. So to neutralize, you know what, like minus 72 can never be an index. An index starts from 0. To neutralize it, we can add 72 everything to both of them, okay? So this becomes to 0. This is okay. This becomes 0 on adding. But on adding 72 to this, it becomes nothing but 144. Okay, 144. Now the point is that to store from 0 to 144, you need a size of 145. So that is it. Okay, that is the 145. Now let's check the initial stages of the DFS. Initially, the length we start from 0. Okay, tight, it is tight. Initially, it is tight. Um, this is 2, right? This was length, type, start. Okay, so has it started? No, it hasn't started. So there are leading zeros, right? Because there is nothing, that means there are leading zeros. Initially it is 72. I just told you why, right? This is 72. So like, sorry, minus 72 plus 72. So initially the difference is 0, but since we add 72 to everything, so it becomes 0 plus 72, 72. Okay, so we start with 72, and then the difference is also 0. Let's dive deep into the DFS part. This is the DFS part where we have the difference, length, everything. Okay. Now, if I is the end of the string, then we can return that if it has started and difference is 0. Always remember, I make difference is equal to 72. Okay. This doesn't mean that the difference is 72. It means the difference is 0 because we are adding 72 to everything. So if I is equal to str.length, return start is equal to 0, start is equal to 1, and difference is equal to 7. Great. If dp of I, so if we have already got this specific, this specific state, if it is not null, that we have already traversed through this, then we can directly return that. If we haven't traversed through it, then we have to think of something. We have to get the answer out of it. There's a limit. Okay, I just told you what about the limit. This is the limit thing that I was telling you, right? So what is the limit of this? So always remember, this is what we are going to consider. This is the condition that we are going to consider. This is just an example that I was showing you, okay? So there is always a limit of this because we are always considering less than equal to L, right? So we are going to consider the less than equal to condition. So this is the limit of this. So it depends. If the earlier position, if till now it was tight, what is the limit of it? It is this number. But if it was not tight, then we can go on till 9, right? That is the whole thing, the whole concept. So we also do it over here. That is, if it is tight, it is the number that is over there. Otherwise, it's 9. Then we traverse from 0 to limit. Okay, and we do all of them because this is like recursion. We do all of them. We check with all of them. So what is the new tight now? Okay, the new tight is if earlierly the tightness has been loosened. Okay, if we have lost the tightness, so the new tight is also lost. Okay, because you have already lost the tightness. Once you lose the tightness, you can't get it back. Simple. Sounds very bad, but yeah, that's the whole thing. Okay, so once you lose the tightness, you can't get it back. Now, since you have lost the tightness, so you can make it directly zero. But let's say if it was tight till now, then how can you consider it will be tight for now also not or not? It will be tight only if the current element is touching the limit. Okay, that is, let's say we are having 1, 2, 3, and 1 whatever it is. Okay, so let's say we are having 1, 2, and 3, right? So over here, let's say we have a 1, right? So the moment this becomes 1, we lose the tightness. But if this is 2, we keep it. Now over here we put anything. We have already lost the tightness, so we don't need to focus on anything. But over here, since the tightness is still intact, so we have to check if the tightness is intact and this is 3, then also from here also the tightness will be intact. Okay, but if it is not 3, if it is 2, let's say, then the tightness is not intact. We are okay to lose the tightness. Okay, so that is the whole thing of the new tightness. New start. What does start means? That is, the number has started. The leading there are no the leading zeros are not there. So we have started forming the number. Let's explain you what I'm trying to say. Let's say you want to make 1, 2, 3. You can make it like this, right? 0, 0, 0, 0, 1, 2, 3, right? You can make it like this. So if you're at this position, you have not started it. At this position, you have not started it. This position, you have not started it. This position, you have not started it. This position is started. Okay. Which means that if you have started it, let's say at this position, has it been started? Yes, it has been started because you have already started it. And if you haven't started it, you have to check that that element is not 0. Then you have started it. Okay. That is, earlier you have started it, or that element is not 0. Then you have started it. Okay. And diff is basically diff. Currently, I'm going to focus on diff and length. Okay. That is n diff and n length. So initially, let's say it is now n diff and n length. But now we have to modify them also. What is a new diff? What is a new length? Okay. If the new start is equal to 1, which means that it has started. So whatever you are adding, it is going to be contributed to the length. Okay. So length becomes plus plus. Okay. Length becomes plus plus for sure. And now whatever the length is, if that is odd, then we add that digit to the difference. Otherwise, we subtract that digit from the difference. Okay. So we have got the state of all the new elements. We have got the new type, we have got the new start, we have got the new difference, we have got the new length. And the new index is nothing but I plus 1. That is, you're putting one step ahead. You're going one step ahead now. So answer plus is equal to DFS of I plus 1, new type, new start, new diff, new length. Okay. And at the end, you will return DP of I of that, and you can assign answer to that. So that at a later point, so that what happens that at that later point, if you get that specific state again, you don't have to compute this whole thing because you have already computed it and you put that to the answer. Okay. So I hope this marks the end of today's video. Thank you guys for joining. Okay, yeah, let me read the problems quickly. first question was easy. The second question was also easy. The third question was smallest ones, a little bit on the harder side, also easy. Okay. Third question was hard. Sorry, the fourth question was hard. So I think this is the rating of today's contest. But yeah, for our thing, like you can also put this ABC also over here. But yeah, they were on the easier side only. All three of them. I think all three of them ABC were on the easier side. It was like very easy to do it if you know about it. Okay. But that too just for the respect of the question, I'm giving it medium. But otherwise, I think it was quite easy. So yeah, guys, that's it from my end. Whoever joined, thank you for joining. Today's live stream was a little bit less interactive, but not an issue. Thank you guys for joining. Bye.